Hello and welcome to the Page of Math. This is lesson 1.2, Solving Basic Equations, where I attempt to teach you how to think about math in an intuitive way. Starting today, we have a story of bunnies. We have a good bunny represented by the black figure and a bad bunny that is red. Now, when these two bunnies meet each other, they fight and they're both destroyed. They go away. So one good bunny, one bad bunny fight it out, and they both perish. It's a gory story. Let's say another good bunny is added. So the original good bunny, bad bunny, they're gone, but one good bunny is left. We're going to represent this in math by saying that the good bunnies are plus ones. So two of them would be a plus two. A bad bunny would be a negative one. And when we add those bunnies together, just like in our little story, we were left with one good bunny. So let's say it's the next night and good bunny comes back with a few more friends. Bad bunny comes back with a few more friends. And just like before, each bad bunny battles a good bunny and they get tired, they go away. And in this story, we have one bad bunny that remains. So let's translate this into math. We have a positive one for each good bunny and a negative one representing each bad bunny. I draw a circle around the pair of bunnies that are fighting, and we have our sole bad bunny that remains, represented by -1. Each of these pairs of numbers are called zero pairs. A zero pair is a pair of numbers that are its opposite. So when added, their sum is 0. I draw a circle around those pairs and I cross it out to remind myself that it's been eliminated, it is gone. So here are a few more examples of a zero pair numbers. We have positive 10, positive 22, and positive 87. And their opposites are negative 10, negative 22, and negative 87. And again, when we add these numbers, we get a 0 each time. Let's take a real world example. We have Grace. She's going to fetch a ball. Let's say she starts at 0, runs out 20 feet, and comes back 20 feet. She didn't lose 20 feet, but she went in the opposite direction, so we can represent that by negative 20 feet. Same distance, but in opposite direction. Let's look at an example where we do not have an obvious zero pair. We have a positive 7 and a negative 3. So we'll use black chips to represent the 7 and red chips to represent the negative 3. A black and a red make a zero pair. We have 3 of those and a remainder of positive 4. Our next example looks very similar to a problem I introduced in the last lesson, where we had 5 chips on the left side of our equation and 2 on the right. And when I placed these chips to represent this equation, in order to, make our left side match our right side, we would need to take 3 chips away. But we can't exactly do that in math. We have to follow some rules. Taking away doesn't quite exist. Think of it like we are operators and we have to add something to the equation every time we make a choice. And in this case, if we have positives that we want to eliminate, we need to add negatives. That is our version of taking away or of subtracting. Think of it like Grace. She started at 0, ran out 20 feet, came back 20 feet, and ended up at 0. But she didn't lose 20 feet, she just went in a different direction. Moving away from poker chips, I'm now going to use symbols to represent our positive and negative integers. In this problem, we want the left side of the equation to look like the right side of the equation. We need to eliminate the two positives, so we would have to add two negatives in order to make two zero pairs. There's our zero pair. And we can always go back and check our work, and I'll show you how to do that in the next method. Method 3, we are decomposing our 5 into two quantities that add to 5, and one of them just so happens to match what is on the right side of our equation. So I know I need to keep the positive 3 and eliminate the positive 2. In order to make a zero pair, I would have to add a negative 2. And again, that is what C would have to equal to make our equation true. The next two problems are pretty self-explanatory. I'll let you watch them and feel free to speed through as you see fit. And again, trying to move away from using the poker chips to using positive symbols for our positive integers and negative symbols for our negative integers. I do want to point out the importance of checking your work. So once you've determined what a variable might equal, be sure to go back and substitute that number into your variable and make sure that the math equation makes sense. If it makes sense to you, make sure to check your work at the end and then check your work against my work and see if you agree. And if you don't, let me know. We can talk about it. We went over a lot of vocabulary today. We talked about opposites, which we will see as a negative sign in front of a number, Integers are whole numbers and their opposites. Zero pairs are two numbers. When we add, they sum to 0. Ninjas and bunnies are a couple ways you can think about visualizing positive and negative numbers. I did not use ninjas in this video. I use bunnies instead, but ninjas work, and anything that you feel work, so long as you're choosing two colors that are not the exact same. All right, thank you for watching. See you on the next one.